Oh, okay. Find the area of a quadrilateral if PS is parallel to the y-axis. So the quadrilateral is quadrilateral PQRX. So from this, you notice that we have a trapezium. As you can see, one pair of parallel side. This line is parallel to this, and this is nice. So this is a trapezium. We know that area of a trapezium is always half the sum of the parallel sides. That's the sum of this length PQSR times the height, which is QR. But we have some problem here because we don't know the coordinate of X and R. So what I will do, I will say let's from here. Okay, as you can see, px is parallel to y-axis, meaning that the x coordinate of x will be 1 since we have 1 here, but we don't know the y coordinate. So this is 1 comma a, and again here we have r on the x-axis, meaning that the coordinate of y is 0, but we don't know the coordinate of x. So I'm saying that this r will be b comma 0. So we need to get the values of a and b so that we can get the length, distance, SR, and this. From there we can solve the area. And this line is parallel to this, and that same line is perpendicular to this. So what will come to our mind is slope of this line and line. So from here, the slope of line PQ is equal to 5 minus 3 over 6 minus 1. So we have 2 over 5, which implies that the slope of line QR will be minus 5 over 2. Remember that are perpendicular lines, so the product of their slope must be minus 1. That's the relationship between two perpendicular lines. The product of their slope must be minus 1. So as this is 2 over 5, this should be minus 5 over 2. So that one is settled. So with that, how can we get the value of b? You know, in mathematics, whenever you are looking for an unknown, you need an equation. Yes, meaning that we'll get the equation of this line. From there, we can get our unknown. And since we've known a point on the line and the slope of the line, which is minus 5, we can get the equation. So equation of line QR. So using point slope form, we have y minus y1 is 5 is equals to the slope is minus 5 over 2 times x minus x1 is 6. So point slope form of equation of a line. So we have that y is now equal to this minus 5 over 2x, and this is plus 15. 5 plus 15 is 20. You get, if you multiply this and this, we have 15. So 5 plus 15 is 20. From there we can get the value of b. So at point r is b comma 0, meaning substitute x as b and y as 0. So I have 0 is equal to minus 5 over 2b plus 20. So which implies that b will be 8. 8. So with that, we've known the value of b. Coming to this, to get the value of a, also we need the equation of this line. We need an equation for us to get an unknown. So get the equation of this line. Since we've known a complete point, we've gotten the value of b, which is now 8, 0. We can get the equation because the slope is the same as this. So at the equation of ROS is now equal to y minus y1, which is 0, is equal to the slope is the same as slope of PQ, which is 2/5. X minus b is 8. So we have that y is 2/5x minus 16/5. So at x, which is 1, a, meaning substitute y as a and x as 1, 2/5 times 1 minus 16/5. So this is minus 14/5. Since we've known the values of the unknown, we need to get the length so that we can get the area of the trapezium. So let's move to another page. So let's get the distance and the area. So let's demarcate this. So from the diagram, distance PQ is equal to, using distance formula. Okay, let's just copy this so that it will be easy for us. We've known the value of so PQ is equal to the square root of distance formula, which is 6 minus 1 all squared plus 5 minus 3 all squared. So this is 5 squared, which is 25. 25 plus 4 is 29. So square root of 29. So YQR. Remember, I've gotten the value of this as 8, 0. So this is 6 minus 8 squared plus 5 minus 0 squared, all in square root. So this is 6 minus 8 is minus 2, so 4 plus 25 is also 29. Square root of 29. Y ROX is square root of 8 minus, the coordinate of x here is 1. 8 minus 1 squared plus 0 minus, I think what I got is minus 14/5. So minus, so we have plus 14/5 squared. So 8 minus 1 is 7. And we know that 7 squared is 49. So while this is 14 squared is, we have 7 squared plus 14/5 squared. So we need to make it easy by factoring. So what I will do, 14 is 7 times 2. So we now have, okay, let me just write, this is 7 squared plus 14. 14 is 7 times 2/5 all squared. 1 is square root. So we have 7 squared in both, so 7 squared, square root of 7 squared is 7. We are left with 1 here, and we are left with 4 over 25. So 1 plus 4 over 25 is 29 over 25. So which is square root of 29 is square root of 25 is 5. So that's the fastest way. So we factored 7 squared, and square root of 7 squared is 7. We are left with 1 plus 4 over 25. And 1 plus 4 over 25 is 29 over 5. So square root of that is this. Therefore, the area we are looking for, which is a trapezium, is half the sum of the parallel side, which is PQ plus PQ is 29. PQ is square root of 29 plus y ROX is 7 square root of 29 over 5 times QR, which is square root of 29. Okay, so we have that the area of the trapezium is now equal to half. As you can see, we have root 29, so you factor it. So we are left with 1 plus 7 over 5. And 1 plus 7 over 5 is 12 over 5 times root 29 times root 29 is 29. So do you get what I did? Root 29 is common, so factor it. Root 29 times root 29 is 29. We are left with 1 plus 7 over 5. And 1 plus 7 over 5 is 12 over 5. So that's how we got this. This 6. So I have 6 times 29 is 174. That's 6, 2 in 12, 6 times 29, 174 over 5, which is this 3 in 24 is 4, and 4 is 8. So that's the answer. So our answer is 34.8. So it's a nice question. Thank you.